Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss a real myth going on among the students about thermal expansion. And in the later part of this video, we are going to discuss the apparent expansion of water filled in a container. First of all, uh, let me ask you a question that this is a this is a rectangular sheet in which there are two discs are taken out, due to which there are two circular cavities created in the square sheet. And the radius of this cavity is A, the radius of this cavity is C, and the distance between these edges of the cavities is B. And in the similar case, let us see that there is a disk whose radius is B, and we have taken out another disk whose radius is A. And this distance is D. Now we are increasing the temperature for both of these substances. Then let us see that what would be the effect on A, B and C, A, B and D. So we might think that due to the thermal expansion, this substance will expand, and therefore these both circles will expand and the distance between these circles will decrease, B will decrease. So a general answer which I came through from the students, that A will increase, C will increase and B will decrease. But you should always remember that in the thermal expansion, each dimension of the solid will increase. Obviously we are referring to that solid whose coefficient of expansion is positive. So in thermal expansion, if we increase the temperature, each dimension of the solid will increase only. Which means that if we increase the temperature, A will increase, C will increase and B will also increase. A and B will increase in such a way, and this sheet will expand in such a way such that these edges will go far away from each other, and therefore B will increase. And in the similar way, let me explain in this case that obviously A will increase, B will increase, and you can see that initially B is greater than A. Therefore the change in B will be greater than the change in A, which means that D will also increase. What I mean to say is that when this outer edge of the disk is increasing more as compared to the inner edge, then this D will also increase, obviously. So this is a very common myth which is going among the students, but now it should be resolved that in thermal expansion, each and every dimension of a solid will increase only. Okay. Now let us discuss the apparent expansion of a liquid in a container. Now there is a liquid filled in a container, and the container has been marked with the scale. We can initially measure the level of the water in the container, and therefore we can initially measure the volume by multiplying that length with the area of cross section. Now the coefficient of thermal expansion of liquid is rho L, and the coefficient of thermal expansion of the container is rho S. Okay, rho S means thermal expansion coefficient of solid, and now let us denote it with gamma S and gamma L, volumetric coefficient of expansions. Now we know that if only if, let's suppose, gamma S is 0 and gamma L is non-zero, which means that the liquid can expand but solid cannot expand, container cannot expand, then on increasing the temperature, the change in volume will be original volume into gamma of liquid delta T. And now if we see that if this gamma S is not 0, which means that container can expand, and gamma L is 0, which means that liquid cannot expand, then we can say that the reading of volume in the container will decrease. Obviously, I'm not saying that the real volume of water will decrease. I'm saying that the reading of this volume of the container, in fact, the reading of the water in the container will decrease on this scale, because obviously if scale is expanding, then these marks are going away from each other. Each division is going far away from neighboring division, then the value of one division will increase, and therefore the volume of liquid in the water as read by this scale will decrease. So therefore we can say that the decrease in reading of the volume will be minus V naught gamma S delta T, where gamma S is the volumetric expansion coefficient of solid. Now, if obviously we have to study that case in which both are not 0. So, if gamma S is also not equal to 0 and gamma L is also not equal to 0, then the total net delta V will be V naught into gamma L minus gamma S delta T, and therefore we can say that the final volume will be V naught 1 plus gamma apparent delta T. I am referring gamma apparent to gamma L minus gamma S. This is gamma apparent. So this is the apparent expansion of the container, and this is the direct formula which I have derived for you people. So you can use this formula and you can solve the numericals based on this apparent expansion of liquid in containers. Thank you.